Hi everyone, this is Miss Temez doing the enrichment video from week 1. So April 16th was our class chat, and this is better than what I was doing at that time because my pen didn't work. Well, now it does. Okay, so first you want to distribute the thing that is touching the parentheses. So since that 2 is right next to the parentheses, you're going to distribute it and get 2x plus 8. And then the minus 7x is just hanging out at the end, and you're going to just keep that at the end. Now you could combine like terms. 2 has an x, negative 7 has an x, and when you combine those, you get negative 5x plus 8. And that's your final answer simplified for that expression. The next one, again, this 2x squared is hanging out there. You're going to multiply the negative 5x, negative 5 with the x squared, and then negative 5 with the negative 1. So 2x squared is just there in the beginning. It's not touching the parentheses, it's not near the parentheses, so it's just there. Then you get negative 5x squared. And then remember, since you're multiplying negative 5 and negative 1, you're going to get a positive 5 at the end. And now the things that we can combine are 2 minus 5, so we get negative 3x squared plus 5. The last one are two polynomials, two trinomials, because they have 1, 2, 3 terms each. And so when you have something like this that isn't just one thing multiplied, you should draw a grid for tabular method multiplication. When you have a 2 by 2, it may be easier, but when you get into 3 by 3 or 2 by 3, I like drawing the grid because I'm able to quickly see if there are any errors where I multiplied compared to just doing FOIL or distribution. Distribution, you'd have to multiply this with each one of these, and then the second term by each one. So you're going to end up with 9 terms anyway, and then combine the like terms. So the first one I'm going to write on top, 2x squared minus 5x plus 1. And then this one I'll write on the side, x squared plus x minus 2. And then to fill in the boxes, we're going to multiply. And when you multiply, you change the powers, because this is the coefficient, the number 2 times the number 1. So 2 times 1 is 2. But then I have x squared times x squared. And when I multiply, x squared times x squared is x to the 4th. Negative 5x times x squared is negative 5x cubed. And then this column is all just times 1, so 1 times anything is just itself. I'm going to get an x squared, an x, and a negative 2. You could fill them out in any order. 2x squared times x, that's a 2, and then x squared and x is x cubed. Negative 5x times x is negative 5x squared. And then negative 5x times negative 2 is 10x. And 2x squared times 2 is a negative 4x squared. So now if you have every term, and I mean every term that there's an x squared, an x, and a number lined up in standard form in the right order, they should work diagonally. So this first diagonal is 2x to the 4th. And I'm going to write my answer over here. And then cubed, I have negative 5 plus 2, which is negative 3x cubed. And then squared, I have 1 minus 5 minus 4. Negative 4 minus 5 is negative 9, plus 1 is negative 8, x squared. And then 1 plus 10x, so that's 11x. And then negative 2 doesn't combine with anything because it's at the end. Okay, so when I multiply a 3 by 3, and they both have x squared as the highest power, x to the 4 should be the highest power there. The next page, sorry I didn't delete my chicken scratch from yesterday. That's not what I wanted to do, but I wanted to point out that these two are the similar and these two are similar. Oops. So the first two are the same except one has a negative and one has positive in the middle. That is called difference of squares. That last D is really small. Squares. Difference means subtraction. Squares means I end up with an answer like this, squared with a negative in the middle. Now, if you don't recognize that it's difference of squares, you could always do a 2 by 2 box. And I'll show you why you end up with only 2 terms. Usually when you multiply 2 by 2, you get a quadratic, which is sometimes 3 terms. But you end up with 2 terms because I have n negative 5 here and n plus 5 here. And when I multiply, I get n squared, negative 5n, 5n, and negative 5 times 5 is negative 25. So when I multiply this middle diagonal, negative 5 plus 5, they cancel out. So the only thing you're left with is n squared and negative 25. So if you recognize that it's difference of squares, you could multiply the first things, 4 by 4, 16. Put a negative because it's difference, it's always going to be a negative. And then you have y times y, so you get y squared. And that's the answer. You could do a 2 by 2 box, but if you recognize difference of squares, it's much easier. The second two are called perfect squares. And they're called perfect squares because it's the same thing multiplied by itself. Y it has the squared, oops, that's a Q. Y it has the squared exponent, the 2 with the exponent. So this, sometimes people just multiply everything by 2 and get 2k. This one is the same as k plus 10 times itself, k plus 10. And when you do the tabular method, the 2 by 2, probably hear a difference in my voice today compared to yesterday. I'm not freaking out over my stuff, my software working. So when you do a 2 by 2 with that one, these, I'm going to get 10k here and 10k here. These aren't going to cancel out. They're going to add together and get 20k. So whenever you have perfect squares, you could square the first thing, multiply these two together, 10k, 10 times k, 10k, but then you know there's 2 of them because it's squared, so you get 20k, and then you square the last thing and you get 100. If you want to do the tabular method, the grid, the box, every time it works, a 2 by 2. Okay, so here is, I'm sorry I didn't delete that lesson 2 module 4. So here are some quadratics, and why they are quadratics is I have x times x and I end up with an x squared. But it's x plus 7 times x plus 3. Usually I've been showing you, you write the x plus 3 on this side and not on this side. So here we multiply them, we add these together. Your final answer, I think I have it over here. Oh, I do. Is x squared, 10x, and 21. Likewise, even though this one has more than one x, you still end up with an x squared. So you get 2x squared, and then you get 9x plus 4. And I think that one's over here to the right too. Maybe not. No, nowhere. There it is. It's on the bottom. Oops. Showing the whole problem on the bottom. So, oops, there. Okay, so you end up with 2x squared plus 9x plus 4. Okay, so usually we do 2 by 2s for quadratics because you need an x squared for a quadratic. So likewise, here we have 2 by 2s. Now I'm going to show you this way, the tabular method, and then the next one I will show you how to do it with FOIL, and then I will show you number 3, how I multiply them, and it goes pretty quickly. Once you learn FOIL, goes pretty quickly. You just do it in your head. So first you get x times x squared. Now, I mean, nothing more is required for you to learn how to do these quickly. I think accuracy is better than speed. I've just been doing this many more years. So this one is x squared. 1 minus 7 is negative 6x, and then I have a negative 7. So that's a quadratic, it has an x squared. This one, FOIL, stands for first, outer, inner, last. The first terms are x times x, x squared. The outer terms are x and negative 3. Negative 3 and x. Negative 3x. Oops, I'll write it over here. The next terms are inner, and outer and inner could be switched because you just need them in the middle, the outer and inner. Inner are these inner, so they're inside the parentheses, negative 5 and x, negative 5x. And last are these numbers that don't have an x, negative 5 and negative 3, which is negative 15. So you have this, but you need to simplify it because it's a quadratic, but these x's should be combined in the middle. So your final answer should be x squared minus 8x minus 15. Okay, so I never learned the tabular method. I do like it for bigger polynomials that you're multiplying, like a 2 by 2, I mean a 2 by 3 or a 3 by 3. But the way I do them first, so I get x squared. I see this number, I multiply 9x and 2x. They're both positive, so I add them together. 9x plus 2x is 11x. And then I do the numbers. 9 times 2 is 18. And writing them in this form with the highest power first is standard form, which is always nice. I'm not going to do the fractions today. Okay, the last thing were these factor puzzles, and it seems like my writing was kind of okay, except for maybe this one, this one, those 4s. Can you tell that's a 4? Okay, so I will go through them right now. I'm going to use red again. So the factor puzzles, you have a top number and a bottom number. You need to think what two numbers multiply to 16, but when I add them together, they add to 8. So 4 times 4 is 16, and when I add 4 plus 4 is 8. So what two numbers multiply to 9? That's a multiply to 9, and when I add them, I get 10. Now I'm telling you from experience, many people get stumped, but remember, we always have 1 and the number, and if you can't think of anything, go through the factors. 9 is prime, so it's actually just 1 and 9. But here, 16, I could have had 2 and 8, but those don't add to 8. I could have had 16 and 1, those don't add to 8. So think of the different factors of that top number and which ones add to the bottom number. Now this one is 78, so 1 and 78 don't add to 41, but 2 and 39 add to 41. And then the last one is 99. 1 and 99, no. 2 doesn't go into 99 evenly. You could use that multiplication table on the back of your little composition notebooks, or you could use a calculator to figure out the factors. But 3 times 33, much better 3 than yesterday, add up to 36. Okay, so this is the enrichment for Algebra 1, Week 1. Let me know if you have any questions. Thanks, guys. Thanks for joining yesterday. I'm actually waving and you can't see me. Okay, bye.